Welcome to GSD Brainers, the place where curiosity meets discovery. Have you ever stopped to ponder the question, how did we get here? The origin of life on Earth is a profound enigma that has engaged scientists, philosophers, and thinkers for centuries. This grand mystery of existence has spawned a plethora of theories, each attempting to unravel the intricate tapestry of life's beginnings. From the depths of the primordial soup to the far reaches of the cosmos, each theory brings a unique perspective to the table. Today we'll delve into some of the most intriguing theories of how life may have originated on Earth. One of the earliest and most famous theories is the primordial soup theory. This theory postulates that life began in the primitive oceans of the Earth over 3.5 billion years ago. Picture this: a world with no life, just an ocean teeming with simple organic molecules. These molecules aren't alive, but they're the building blocks of life as we know it. In this vast prehistoric ocean, these molecules were exposed to various energy sources such as heat from volcanic activity or lightning from thunderstorms. This energy could have jump-started chemical reactions, encouraging these molecules to bond together to form more complex structures. Over time, these structures could have become even more intricate, eventually leading to the first living organisms. These early organisms would have been incredibly simple, likely just self-replicating molecules. But from these humble beginnings, life as we know it today could have evolved. Every plant, every animal, every human could be traced back to this primordial soup. However, it's important to note that this is just a theory. While it provides a compelling narrative for the origin of life, it is based on a series of educated guesses and assumptions. Scientists are still working to test and refine this theory, and the exact process of how life began remains one of the biggest mysteries in science. While the primordial soup theory paints a fascinating picture, it's not the only explanation scientists have proposed. Imagine if life on Earth didn't start on Earth at all. A thought-provoking statement, isn't it? This is the basis of the Panspermia Hypothesis, a theory that suggests life might have hitched a ride to our planet from the vast expanse of outer space. The concept of panspermia is as intriguing as it is mysterious. It posits that microscopic life forms or biochemical precursors of life could have been transported to Earth aboard comets or meteorites. Imagine a comet hurtling through the cold vacuum of space, carrying within it the seeds of life ready to bloom on a suitable planet. And what if Earth was that suitable planet? The idea is not as far-fetched as it might initially seem. Our planet is bombarded by tons of extraterrestrial material every year. Most of it burns up in the atmosphere, but some makes it through, potentially bringing with it extraterrestrial life forms. The Panspermia Hypothesis is not without its challenges, though. For one, surviving the harsh conditions of space and the violent entry into Earth's atmosphere is a tall order for any life form. But if life is anything, it's resilient. And who's to say it couldn't have found a way? The Panspermia Hypothesis takes us beyond our planet. But there are still more theories rooted firmly on Earth. So let's dive back down to our home turf and explore the mysteries of life's origins further. Beneath the ocean's surface, in the deep sea, life might have found its first foothold. Let's dive into the hydrothermal vents theory. This proposition suggests that life on Earth may have begun not on the surface, but in the scorching and mineral-rich environments of hydrothermal vents. These underwater chimneys spew out superheated water that's laden with minerals. It's a harsh environment, to say the least, but it's also a potential breeding ground for life. The theory suggests that the mineral-rich water, coupled with the energy from the Earth's core, might have provided the perfect conditions for the formation of simple organic molecules. Picture this: these molecules, over time, began to form more complex structures. They started interacting, sharing, and eventually creating the first rudimentary cells. It's a bit like cooking a pot of soup. You start with simple ingredients, but with the right heat and time, you end up with something much more complex and nourishing. So why do scientists consider this theory? Well, even today, hydrothermal vents host an abundance of life, from weird and wonderful tube worms to heat-loving microbes. These organisms thrive in conditions that would be lethal to most other life forms, showing us that life can indeed flourish in the most unexpected places. These hydrothermal vents might have been the cradle of life, but can we recreate these conditions today? With all these theories, scientists today are trying to recreate these ancient conditions. Imagine a room filled with beakers, test tubes, and controlled environments, all meticulously arranged to simulate the primordial conditions of our planet. This, my friends, is where modern-day alchemists, also known as scientists, are seeking to unravel the enigma of life's inception. Scientists are working tirelessly, using cutting-edge technologies and innovative methods to simulate the environments proposed by the theories we've discussed. From concocting their own versions of the primordial soup to mimicking the extreme conditions of hydrothermal vents, they are leaving no stone unturned in their quest. Let's take a moment to appreciate the successes in this field. A prime example is the Miller-Urey experiment. Conducted in the mid-20th century, Stanley Miller and Harold Urey simulated early Earth's atmosphere in a lab and managed to produce amino acids, the building blocks of life. This was a monumental achievement, demonstrating that life's basic components could indeed form under these ancient conditions. In recent years, scientists have made further strides. They've managed to create protocells, simple cell-like structures in lab conditions. These protocells can carry out basic life functions, such as metabolism and replication. The creation of these structures is a significant step towards understanding how simple organic compounds could have evolved into complex life forms. However, these experiments are not without their challenges. One of the biggest hurdles is the complexity of life itself. Even the simplest life forms are incredibly intricate, and recreating them in a lab is a monumental task. Furthermore, these experiments can only offer insights into possible scenarios. They cannot definitively prove how life originated. Despite these difficulties, the efforts are far from futile. Each experiment, each discovery is a piece of the puzzle, aiding us in understanding the intricate tapestry of life. As we continue to probe and question, we are continually reshaping and refining our understanding of life's origins. While the mystery of life's origins remains unsolved, each new discovery brings us one step closer to understanding our own beginning. That's all for today, folks. For more brain-boosting content, hit that like and subscribe button. Thanks for watching.